The figure below shows a graph of a car's position as a function of time. Find the velocity of this car over the following time intervals and indicate the direction of velocity with the sign of your answer. First, it asks for the interval from 0 seconds to 4 seconds. So in this situation, our time axis is the horizontal axis. 0 seconds is going to be located right here on the vertical axis. And then 4 seconds is going to be here. So we should trace that up to see where it intersects with the curve. So I could call these 2 points point A and point B. In order to calculate the velocity of the object, I'd like to know the coordinates of those 2 points. So A's coordinates are going to be 0, 0. It's at the origin of the coordinate system. B's coordinates are going to be that we would start with the horizontal value first. So put a 4 here, 4 seconds. And then what we want to do is trace that point over to the vertical axis to find the position, which is the x value of the thing. And so that's going to be a 6 meters. So using these points with both the horizontal and vertical components, I can now calculate the velocity of that segment. This is a general formula for velocity. We need to know a time interval in order to calculate an average velocity. So it has to have both a start to it, a starting time, and an ending time. We have that here. Our starting time is going to be the 0. Our ending time is going to be the 4. So the 0 is what we call TI, and the ending time is TF, that's the 4. So for this particular part of the problem, we're going to be doing average velocity from t equals 0 seconds to 4 seconds, given by our final position minus the initial position divided by the final time minus initial time. So let's get our final position. So our final is going to be the 6. That is this value right here. Our initial position will be the 0. So our vehicle, if we were to draw its motion, it's going to start here at the x equals 0, and it's going to go up to a final location of 6 meters. This is a one-dimensional motion problem, so the car only really moves in one dimension of space. Time is not a location in space, so none of the horizontal information tells us about a location of our car. Only the vertical information tells us that. Okay, so we're going to need 6 meters minus 0, and then we'll divide by 4 seconds minus 0. This gives us 1.5 meters per second for that first leg of the trip. Now we want to change our time interval to starting at 4 seconds and ending at 6 seconds. So here's the 6 second mark. We should trace that down until we hit the curve. I'll call this point C. And we'd like to know what his coordinates are. So the horizontal component is going to be that 6 seconds. And if we trace the point over to the vertical, we see that it actually has a vertical value of -4. And now we'll just do the same kind of calculation as before, but we'll change our time interval. We're now going from 4 seconds to 6 seconds. So I'm talking about this interval right here. We need the final x minus the initial x for that interval over the final time minus the initial time for that interval. If we look at our vertical value though for point C, that's a -4. That's our final location. So what the car really does during this segment is it turns around and goes back to this kind of location here. And so it used to be going in the positive x direction. That would be forward motion. But now in the interval from B to C, that car is going backward. Okay, so let's let our final location be -4 meters. Our initial location was 6 meters. And then we'll divide by the time interval of 6 seconds minus 4 seconds. Talking about this time minus this time. So basically, the blue values go on top. These are the positions. And the yellow values, the times, go on bottom. So the total change there is -10 meters. It takes 2 seconds, so we're talking about -5 meters per second. This was for part B. Now let's look at part C. Part C says we're going to go from the time of 6 seconds to the time of 10 seconds now. So 10 is here. If we trace that down, we could create point D. And his coordinates will be 10 seconds, comma, -4 meters. Interestingly, he's got a different time than point C, but the same location as point C. Because if you trace point D over to the vertical axis, it also hits at -4. This indicates that our car doesn't go anywhere during that interval. It's in a situation which would be called rest. And so if I was to draw another iteration of the car, it would simply be located in the same location as it was at point C. So this was A, this is B, this is C, and now we're at point D, which is in the same location as point C. Our velocity calculation will be from t equals 6 to t equals 10. And we're going to do -4 meters minus -4 meters. It's important to keep the double negative there in this situation. And we're supposed to get 0/4. This shows that our car's velocity in that interval is 0 meters per second. So it's at rest. Finally, for the final leg of the motion, we'll go from point D to point E. If you trace point E over to the vertical axis, you see that it's actually located at an x of 0. So those coordinates then are going to be 14 seconds, comma 0. And let's use those numbers now in our slope calculation. 0 is the final location. -4 is now the initial location. We always have to do final minus initial in this formula, so we're going to do 0 minus -4 over 14 minus 10. This shows that our car actually moved forward 4 meters, and it took 4 seconds. So this is a positive 1 meter per second velocity. The last leg of our car's motion then is that it's going to return to the location it had started from. It's going to do this. We could tell the whole story of how the car had moved. Let's say that there was some kind of road here and a finish line located at x equals 8. The car started at x equals 0. And what it did was it went forward toward the finish, but it only got to the 6 meter mark. Then our car suddenly turned around, went back to a location of x equals -4. Then our car stayed stationary for just a little bit, 4 seconds, and then it came back to the same location it had started from. So if we turn that analysis 90 degrees, which is a little more relatable to us, to the right is now the positive x direction. Our car goes forward, turns around, goes backward, stops, and then comes back to its original location, never really reaching the flag at an x of 8.